I'm happy to invite our next speaker. So, Robin Moffatt, if you have already joined us, welcome, please.
Okay, so let's go for this again. So my name's Robin Moffatt. Welcome to our session. Today I'm talking all about Apache Kafka and building Telegram bots. And so I want to show you how you can take this idea of being able to find out information about your nearest car parks. So I live in this lovely place called Ilkley. It's in Yorkshire in the north of England. And Ilkley is a lovely place, but there's not tons of like big shops and cinemas. So often I'll need to travel from Ilkley to my nearest city, which is a place called Bradford. And so I'll sometimes drive there, and on the way into Bradford, I'll be thinking, which car park am I going to stay in? Because obviously that's the kind of thing which is on your mind when you're in a car. And I wonder which is my nearest car park that's actually got some spaces, or how many spaces are there in my favorite car park? In fact, maybe there aren't any spaces available. So can you tell me when there are some spaces available? And it's interesting to know, if you want to like analyze these things like data geeks do, how do the car park occupancy vary over time? So I'm a developer advocate at Confluent. Confluent, one of the companies behind the open source Apache Kafka project. And I want to show you how you can take data from an open endpoint. So there's open data in the UK. This one comes from the Bradford Council, and use this stream of data, streaming it into Kafka, and then serving it up through Telegram as a platform. So let me show you in action, and then I'm going to walk through in the time that we've got to actually show how we've built it. So I'm going to head over to here, and on the left-hand side is just like the bot itself that's running. So you'll see the various diagnostics that are going on. And on the right-hand side, we've got Telegram. And Telegram, many of you are familiar with this. It's a messaging platform, just like WhatsApp and Facebook Messenger. And it's got a really good API that you can write bots against. So as my user, sat in their car and either on their laptop, or Telegram's obviously got a mobile client as well, you connect to the bot and you say, right, I'm going to start talking to the bot. And the bot says, okay, here are the different things that you can do. And on the left-hand side here in the bot's back end, you can see we've received a message from the user, and it's this command saying start. So the user can do things like say, well, I would like to know where my nearest car park is. So I'm going to send you my location. Let's do this. And we say, well, my location is here. We're going to send this location. And the bot is going to say, okay, let me go and find out, based on that longitude and latitude that you've told me that you're at, I'm going to find out which car parks there are, where they're at, and like as a crow flies, which one's the nearest to where you are that's got some spaces available. So this is a live demo, so you have to kind of like sit and drum your hands a little bit, because these things don't always work first time, but this one fortunately has. And it says, okay, here's the car park. It's a place called Westgate. It's got these many spaces free. It's like, that's pretty useful. So it's got 103 spaces free. And like here in the UK, we've just locked down again. So there's going to be a bunch of people working from home and not driving into cities. So I'm guessing there's plenty of car parks with lots of spaces free at the moment. But we can also do stuff like this. We can say, well, I would like to know for Westgate, has it still got however many it was, 103 spaces free? Has that changed or not? And it probably hasn't, because the API only refreshes every 3 minutes or so. But we can say, okay, tell me for Westgate how many spaces there are. This is okay. At this particular point in time, so this is Greenwich Mean Time, UTC, there are this many spaces available. So as well as being told, like, here is your nearest car park, we can say, well, go and do a stateful lookup against the information that's streaming into Kafka, and just do a lookup against that information for a particular key. And we could do something like say, well, actually, I would like to know when a car park becomes available with a certain number of spaces available. So let's say I would like to know when there's a car park with more than 500 spaces. So we've created this alert definition. And now when data's received by the bot from the API, which I'm just going to trigger now, we're going to get a feed of data, and we now get event-driven notifications. So here it says, well, here are the different car parks within the area that are kind of like near to you, and they've all got more than 500 spaces. If I change that alert, and we're going to say something like, show me when there's, let's say, alert 10. So when there's 10 spaces, we're now going to get a ton of different car parks coming back, because there's lots more car parks. So you can define a threshold, and this is actually on the left-hand side here, you can see it's actually expressing it in SQL itself. So this is the kind of thing that we're going to build. In a way, it's a fairly silly example, because you kind of know where the car parks are and stuff like that. But being able to take a stream of data and interact with it as a user and say, like, tell me when a condition occurs. So like you can do event-driven alerting. So when an SLA threshold is hit in your monitoring data, or a certain number of orders get placed within the last hour, tell the user about it. Or we can do lookups against that data that's in Kafka also. So let me show you how I've built that. I'm going to kill the bot for now, because otherwise we're going to keep on getting messages popping up in Telegram. So now let's see how it's actually built. So this is what I'm going to be showing you. And the code itself is all on GitHub, so you can go and try it out. But what we're doing here is we're building this thing out. So we're taking data from the source API, streaming it into Kafka, streams into a Kafka topic. We're going to do a bunch of processing, which I'll show you. And then we've got our bot, which is written in Go, which interfaces with Telegram. We're also going to stream the data over into Elasticsearch so we can build some analytics on top of it. So the code, as I say, it's on GitHub. I'll share the links on Twitter and anywhere else I can share them afterwards. But you'll see me kind of like looking up and down, because I'm going to move this onto my bottom screen here so I can actually show you this all in action. So to get the data in, we're going to use the REST API of the information source itself, and we're going to just use curl to ping against it. So we're going to say, show me the data, and it's actually just comma-separated information. I'm piping it through tail to strip the header off, because we've got the different names of the fields and stuff in there. But you can see here it's 6th of November at 8 minutes past 1 in the afternoon. Here's the car park, here's the capacity, here's the number of spaces. And we're going to take that information and we're going to stream it into Kafka. So this is not kind of like a production-ready pipeline. This is kind of like useful for prototyping, useful for building demos, but we're actually going to say take the output of this statement and pipe it into a Kafka cat. And Kafka cat integrates perfectly with the Linux pipelines philosophy. You can pipe data into it from standard out, and you can take consumer from Kafka cat and pipe it out of there and take the standard out into another standard in on another application. So we can actually do something like this. We could say, let's take our command, and we can consume from that topic that we've just loaded to check that the data is actually there. So we're saying, take the data from this Kafka broker, from this particular Kafka topic, -c, consume it. Now it says, here is the data that sits in that topic. And if we tell it not to bot it, it says, here is all of the data that's in that topic. So I'm going to set this running, doing a little polling loop. It's very hacky, but it's actually going to do the job for us. We're going to say, do a forever loop in bash, do this. So pipe that information from the API into this Kafka topic, and then just do it every 3. So let's change that, because it's going to make for a more interactive demo. So every 15 seconds, we're going to get a dump of data of the current state of that API. And it's just going to echo it to the screen here, because we use the -t flag in Kafka cat, which says, send it to the topic, but also write it to the screen. Now, let's go and work with this data. So I'm going to use a tool called ksqlDB. It's part of Confluent Platform, it's community licensed, and it lets you do stream processing on your data in Kafka. So take a Kafka topic, transform it, enrich it, join it to other things, write it back on another Kafka topic. It also lets you act as a database. So when I was doing those lookups, saying how many spaces does this particular car park have, this is looking it up against ksqlDB. So it's built on top of Kafka, and it builds these materialized views of the state on top of a Kafka topic. So it's pretty cool, because it means you can build applications without needing to kind of like take your data and go and stick it into like a NoSQL store or a relational database somewhere else. You can actually have that event streaming database on top of Kafka. So with ksqlDB, we're going to take our stream of data. So I'm going to say show topics. What data do I have in my Kafka cluster at the moment? So it's got a topic called car parks. I can say print car parks from beginning, show me all the data that's in it. And this just acts as a consumer. And it says, well, here's your data. It doesn't have any key. It's got these particular values. And we're going to declare what's called a stream on top of that data. A stream is just a Kafka topic, but has a schema. Because we're working with data, data's got a schema. Schema acts as our contract between our different services that we're writing. So we declare that schema, because at the moment it's just comma-separated values. So we're going to say it's got a date, and it's a varchar. It's got capacity, which is an integer. It's got latitude and longitude, which are doubles. Take that schema and apply it to this topic, and the value format, it's delimited data. We could put this on top of JSON data, we could put it on top of Avro data, protobuf data. However you've serialized your data, you can ingest it and use it within ksqlDB. So we create that stream. It says, okay, I've gone and created that stream. And we say show streams. And it says you've now got a stream called car park source. So let's have a look at the data in that stream. Now, the data in that stream is the data that's in the topic, but with a schema applied to it. And because we've got a schema applied to it, it means we can project fields. We can say, select this field and that field from this place and show me the data, just show me the first 5 rows. So we do that. It says, okay, here are the first 5 rows. And we've got that particular car park there. It's got this many empty spaces. So as the data's arriving in from our source, which is polling that API, piping it into a Kafka topic, we can see that it's flowing into our Kafka topic, and we can apply that schema and those field projections. Now what we're going to do is we're going to take that data, we're going to transform it and write it back onto a new Kafka topic. So we've got source CSV data, which is fine, and it's the starting point for a lot of pipelines and applications, but we want something better than that. We want to derive some fields. We want to be able to do things like say, well, instead of 2 strings here, 1 string describing a date and 1 string describing a time, let's actually make this a proper timestamp and give it a time zone and store it as a timestamp native format. We can also say, well, it's in delimited format. We've had to manually type in the schema. Let's serialize it onto a new topic using a serialization format that supports schemas natively, like protobuf. Because that means that anyone else using that data, whether it's ourselves subsequently or any other application, they now have access to the schema. They don't have to type it in. So we're going to do this. We're going to say create a stream. And this stream, again, is a Kafka topic. And we're going to serialize it as protobuf. And we're going to say take our date and time and convert it into a timestamp. Here's our format. It's a London time zone. We're also going to start deriving different fields. We're going to say, well, let's work out the percentage full. If we know the capacity and the current number of places occupied, we can work out the percentage full. So do these calculations. We can also change the schema of the data that we're writing. We can say, well, take the latitude and longitude and write it as a location object, as a struct, because this actually makes it easier to use downstream. That's logically one object. It's a location object with 2 different fields within it. And we can also add some metadata, kind of lineage, and working out where this data came from. So we're going to go create that stream. And when that stream's created, we'll see that it's actually going to have populated a new topic. So if we say show streams, we've got a stream here called car park events, backed by a Kafka topic called car park events. And we could change that if we wanted to. And it's in protobuf format. If I say show topics, we can see we've got a topic called car park events. And I could also run a consumer against that and say print car park events. It says here is the content of that particular topic. So now we're just running a consumer against the topic, which is being populated continually by that create stream statement. If we just remind ourselves what that looked like, it said create stream as the results of this select statement. And because that select runs against the source stream, which is a Kafka topics are unbounded and continue ever. It's kind of like an infinite stream of events. Therefore, ksqlDB queries, when they run against these streams, are also unbounded. They're continuous queries. So we're saying create this new stream here, populate that target stream with the results of this continuous query. So as every new event arrives in our source stream, which is our source topic, take that event, modify it, and write it out to this new topic. Oops, so we don't want to do that. We don't want to crash the thing because that's a shame. So let's instead restart our client. And once we've restarted our client, we can actually take data and we can start to transform it even more. So over here, my computer's on a bit of a go slow. So we're going to take streams. We've got a stream called car park events. And now we're going to take that stream of information and we're going to build a table on top of it. So far we've taken an inbound topic, we've transformed that topic and written it out to a new one. Now we're going to say, let's take that enriched data with like the struct that we created and the timestamps that we sorted and lineage information, take that and build a materialized view of the state on top of it. So within that, we're going to say, let's set the offset to the earliest, so process all of the data that we've got in that particular topic. And now we're going to do this. Create a table as the results of this select statement. So this statement here is saying, create an aggregate. So we're going to group by the name of the car park. We're going to take the latest timestamp, the latest capacity. We're also going to say the average indices, and the rest of them are just like by offset. So this is the aggregate saying just store the latest value of all these different things from our car park events stream and group it by the name of the car park. So we do that, and we now have got a table. So ksqlDB, we've got streams, and streams are Kafka topics, unbounded series of events with a schema. Tables are also Kafka topics with a schema, but they are the value for a given key. So in our case, this table, the key is the name of the car park, and it's the value. And that value is going to change, but it's going to change in place because it's key value. That's what a table is in ksqlDB. So we can actually query that table. We can say select the latest timestamp, the number of empty places from car park, which is our table, where the name is Westgate. So that's the same one I used earlier when I was running the Telegram bot. And you can see here, so the empty places, earlier it was 103, now it's 105. But you'll notice it said, okay, here is your answer, query terminated. This is what's known as a pull query. This is what the bot was actually doing. ksqlDB saying, select this value from that materialized view that you've built and return it to the user. It's a pull query, it's pulling the value out. So you can calculate these averages and the latest and the sum and the average and all these kind of counts and any other aggregation that you want. And you can store a table, a stateful table, and it's distributed and resilient. And you can query that from your applications. So I'm using the command line interface, but there's a REST API, there's a Java client, there's a kind of community Go and Python clients as well. So you can actually do those lookups against those streams of data. We can also do what's called a push query. So with a push, we're going to take kind of like an event-driven approach to things. So here, we're going to say, tell me, we're going to take the example of like, tell me when there's a space available. So we say, select the name of the car park, the number of empty places, and now we're going against the stream of events. Because in terms of alerts, you want to know based on each event. You don't want to look at kind of aggregate overall. In this case, you're saying when something happens, evaluate it against this predicate. And if it matches this predicate, then tell me about it. And you'll notice at the end here, we're saying emit changes. So rather than just saying select this, and then that's it, and the query terminator, and off it goes, and it returns it back, emit changes says, well, this is what's called a push query. This is a continuous query. So this now goes to our source data, and it says, well, we're going to start from the beginning. We set the offset to the earliest, and now we're going to return every single value that matches this, and then at the bottom down here is press Control-C to interrupt, because it's going to keep on running, and as every new value arrives, it's like if you remember, we've got that source polling of the API here. Every 15 seconds, it loads it into the topic, and so that means that in KC, we get to see that every single time it changes, you get a new result echoed out onto the screen. So that's what's called a push query. And again, you can integrate with that using the REST API, using the Java client, using a Go client. So from your applications, you can do both queries, kind of like event-driven notifications, as well as stateful queries against the in Kafka. So I'm almost out of time, so I'm going to head over to here and just show you a couple more slides to talk about what we've done. So this is what we built out. We said we've got data coming in from our source, streaming it into Kafka. We used a bit of a hacky approach just to pipe it in into a topic. We transformed and enriched it into a new topic with ksqlDB, which we then consumed with our Go client, echoing it out to Telegram. The Elasticsearch thing, let me show you super briefly just to prove that it actually works. You can also stream that data over into Elasticsearch and build a dashboard on top of it. So you can say, well, we've got that longitude and latitude that we built into the objects, so we can actually plot maps based on that data and analyze the data based on it within that. And then we said, what we're going to take within that are some different principles of how we're building applications. So we've got event-driven alerts. So we can say when something happens in this data, then tell the user about it. We can also do lookups against the state of materialized view, which returns straight away back to our client, so Go or Java, whatever you're writing your applications in, out to the end user. And we also applied a schema to that CSV data and re-serialized the data onto a new topic using something like Protobuf or Avro or whatever we'd like to do. So let me share you a couple of resources. And if you follow me on Twitter, I'm at armoff on Twitter, so you can see my handle at the bottom right there. I'm at armoff. I'll tweet some links after this. There's a fuller version of this talk if you'd like to follow it. There's also a blog about it. but I'll finish off by just showing you a couple of these. So there is the demo itself that you can find on the demo scene repository. It's a Confluent repository. So scan the QR code or go to that URL, and you can actually clone the repository. The API is open, so you can try it out for yourself. Go and sign up for Confluent. The demo I'm showing you here, it's actually running on Confluent Cloud as well. So you can then use that as your managed Kafka service. And then head over to developer.confluent.io, where you can find lots of tutorials and podcasts and videos for learning lots more about Apache Kafka and Confluent Platform. So with that, thank you very much. Follow me on Twitter, look me up on YouTube as well. And I do believe we're heading over to Zoom for questions now. Is that right?
Yes, thank you very much, Robin. You are right. You should go to Zoom room to communicate with your participants here and answer all the questions. And you guys, if you enjoyed this speech, you can go to our mobile application and push like button for Robin's speech. Thank you. Bye.